This entire wall will be a screen.
But then they've got to get rid of the shadow.
Many, many moons after we all graduate. Then the Piccone secret whiteboard /
They'll hang that on a different wall
projector
and
screen.
become a senior lab design room dartboard.
Because it's got a
Oh, it just comes out of our. Whenever I decide.
It's the next project, Scott. We get to move that into the senior design, whatever
right.
lab thing, and make it a dartboard instead.
This thing weighs a lot.
Is your webpage
I see what you're going with this.
public yet?
I'm on board.
Oh, it is. I just happen to be on my local one.
I'm not that good at ping pong.
So, the syllabus, you should be able to find it if you go to Rico Piccone.
We all know what
I like the way Scott's brain processes information.
And 454. Okay. So, welcome to Robotics and Automation. How many of there are you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are supposed to be 13, so roll has been called. Excellent.
You're missing at least one.
You're still not my
here,
advisor, so not enrolled.
Ah, so we're missing one.
Yep.
Who's not here?
Chris,
Yeah. Okay.
Is it Mofay or
Now we know. Now we know.
Sounds like him.
When he comes, we'll get him. All right. So, I'm going to be recording these lectures because I found that to be pretty helpful in the. I tried it out last semester a little bit and it worked pretty well. So, we're going to try this. So, this is my syllabus for this class.
Website's updated then?
Website is updated. Yeah, so if you go to my website, it's this tab that says ME454. It should be up there. If it's not showing up, that means that you need to like delete your cache or something. I don't know. So, how do you delete your cache?
No, how you get to that website.
Oh, it's just Rico Piccone with a dot before the O-N-E. It redirects from ricopiccone.com in case there is any confusion. So, but I don't want to be a .com because that's just weird. I felt more comfortable being a .1. I was like, how could I get away with not doing .com? It's like you don't want to do like .net. It just sounds like you don't know much about the internet, and you're like, this domain's cheaper. So, yeah. Anyways, I decided I would just do away with all of it and just put a dot in the middle of my name. I thought it was cool. Other people were like, it's confusing. And I was like, it's okay. If you can't figure it out, I guess you don't deserve to go there. So, this is an elective class. It's a lot of fun. I try to balance the fun with covering cool stuff that we need to do. So I guess like a little overview of the course description. We're going to go through the syllabus today, and we're going to, since we have all 3 hours of lecture, well, it's 2.5 hours, right? 50 plus 50 plus 50, so it's like 2.5 hours of lecture all at once. We're going to do a little bit of seminaring, which we'll discuss, and then we're also going to talk about the project today as well. So we're going to get probably a very full day in on the first day. Even though you guys haven't had a chance to read, we're going to do a little bit different than we will do in the next few lectures. So, I'm supposed to introduce you to robotics and automation. We're going to talk about what those two things are as part of the seminar today, so I'm not going to sort of talk about that at the moment. But the first aspect is going to be a survey of the field of robotics. And we're going to read this robotics primer that I've gone through before with another class. It's really nice. It's real easy read. It's kind of like below the level of what you guys are at, but your baby's in robotics too, so it's not like, I mean, not all of you are. I don't want to claim everyone is, but it's good to get your feet wet. It doesn't get into very many of the technical details. It just gives you an idea of like what's out there, what's the terminology that's used, and it introduces some pretty cool concepts, which I really like, and they're good to discuss. And so we're going to be reading that, and I'm going to be supplementing that with some papers as well. So some weeks I'm going to choose papers for you to read, some like academic robotics research papers. And other weeks you're going to choose your own papers. So you're going to go find your own papers, and you'll be writing a little summary about it each week. So for the first 5 weeks, we'll be doing that. It's sort of like a robotics seminar where we meet, we discuss. There's a lot of interaction. Like I will be sitting with you at this table. Well, we'll see how it works out. I think we'll try to group up, and one big group around the table, and we'll discuss the readings that we've gone through and some of the ideas that were presented. So that's going to be sort of the first third of the course. The second aspect of this course is feedback control systems. So you cannot do robotics or automation unless you know some control theory. And we did a little bit of it at the end of your system dynamics course last year. Well, not for all of you, but it's the part that we talked about before, essentially covered up through very basic proportional gain control stuff. We did PID. Did we do PID? We did lag lead. Yeah. It was really basic stuff. You hardly got to scratch the surface. So this term, I'm going to spend about a third of the term on control theory, maybe a little bit more. We're not going to slice it up into neat thirds either, as we'll see. But we're going to really dig into control theory a little bit more. We're going to be staying primarily in classical control theory. We're talking about what the difference between classical control theory and modern control theory is, but don't worry, classical control theory is still very much alive and well and is used all the time, so very useful. Probably more useful than modern control theory for your average engineer, I would say. Because your average engineer is not going to design with state space, which is what the modern control theory theorist does. So we'll touch on that, but we will do a little bit of state space feedback control as well, so that'll be fun. So there's that aspect of the course. And then the third aspect is probably the part that made you all sign up for the course, is we're going to do a project. We're going to do a project, we're going to build something, okay? And I decided this year, so the first year I did this class, I had the whole course was a project, and day one we just met, we were working on a project together. I thought that the students, it was my fault, students needed more background to be able to do the work that we needed to do in the project, so that wasn't effective. So the second year I made it more theory-based, and there was a little project at the end, and I thought that was better, but I felt like we needed a little more project, so I kind of like overcorrected. So now we're gonna go somewhere in the middle, where we're gonna start talking about the project day one. We're gonna work on it all semester, and we have a little bit larger class than we had about a week ago or 2 weeks ago when I decided that was what the plan was. We had about 10 then, and now we have like 13 or 14. But I still think we're going to be able to do just one project, and we're just going to have teams that meet up and work on aspects of the project. So we'll start talking about that towards the end of today. Yeah.
Do you already have projects in mind, or?
Yeah, actually, I want to do one project. So it's going to be, I want you guys to do one group project where everybody works on the same thing. I know you guys all, well, not all of you, many of you have senior design. So you have a project that you're working on and you're doing builds and you have all that. So I don't want to burden you with a whole bunch more project work, but I think that since we have such a big team, and I think we have a really strong team here, we can really accomplish something cool as a group. So, and this is the size that, you know, you might work on a group of engineers that's around this size. I mean, you probably won't work with them every day, but you and 2 others might work together on an aspect and come together to the group about this size and report. So this is a pretty good sort of emulated environment where you can get a chance to get a feel for how to work through a project. And we're going to talk more about the project later, but every meeting we have, since we have these 2.5-hour meetings, we're going to spend a portion of it doing, so for the first 5 weeks, a portion of it doing a seminar style, and then a portion of it on the project, okay? And so for the first few weeks, and then when we start to switch over to lecture, I will lecture for 5 weeks we'll do the seminar, and then we'll do project, and then I'll be doing lecture and then project afterwards. So we'll be having that every single week throughout the semester. We'll have the project discussions and breakout meetings and design reviews and all of that. Okay, so it's going to be, I'm going to try to treat this, and so I have to play kind of 2 roles here, well, 3 roles. As the project, I'm going to be your customer. Okay, so I'll kind of tell you what the project is going to be, and I'm a little bit open to suggestions for other things, but I thought about this one quite a bit. I think it's going to be a really good one. So I'm going to lay it forth in more detail soon, but I'm going to be a customer who has a manufacturing environment who wants you to design a platform that will catch parts that are falling onto it based on some other apparatus. I'll tell you more about it. It's going to drop them, and it's going to be from a predictable height. But you need to be able to design a platform that can reactively catch these parts as they fall, so that they don't have greater than a certain amount of acceleration, so that they aren't damaged. Okay, so I think it's a doable project, but I think it's a challenging project. I think that it can be done, though, and there's a lot of cool aspects, and we get to use a lot of things from the seminar, but also from the control theory, especially section, and from your other courses as well. So it's going to be a fun project to work on, and I think it has a sort of practical flair to it. I don't have like an actual customer who wants this thing, but it's kind of a cool thing that, you know, you could be asked to do something like this. If you're an automation person, you could be asked to build something like this. So I'm going to be your customer, and I'm going to give you this vague statement at the beginning, where I'm going to be like, this is what I want, and then you guys got to come up with, you guys got to ask me, you guys got to interact with me, like, what do I really want? Make those into requirements, and we'll talk more about that. So I'm going to play that role. I'm going to play the role of kind of helping lead the project, and I'm also going to be guiding you guys through this, because you guys haven't, I mean, some of you have, but many of you haven't really gone through this process yet. So it'll be, I'll try to balance switching roles there, but I think it'll work out pretty well. You guys obviously know when class is. Chris doesn't know, but
The time there is wrong.
what?
Yeah, it's still 3.
Oh, I haven't uploaded that. Sorry. Yeah. This one. There we go. I just haven't uploaded the latest one. This is the latest one. It's my local one. Here. As we speak, it will upload. There we go. It's uploading now. So now we have my office hours, 9:20 to 11, Monday, Wednesday, Friday, or by appointment. So this book, we'll talk about Slack in a moment, but if you're on Slack, you will find that there's a PDF of this book there. It's a really cheap book anyway. It's like, I think it's like 30 to $40 to buy a new copy, hard copy, so feel free to get it if you want, but there's a PDF. It's pretty easy reading. I don't remember how many pages it is, but I assign a lot of reading each week, but it's not difficult reading. So it's pretty good. Then there's the Nice book, which you should still have, hopefully, from your system dynamics course. This is going to give more depth in the control theory and stuff. Hasn't changed editions in a couple of years. The notes section is really the seminar section, so we'll come back into this when we move past the syllabus in today's discussion, and we'll go to the seminar on robotics that we're going to get to. Now, the schedule. So, lots of reading to do. So get reading immediately. You should be able to, because you should have the PDF. Get your Kindle, get a puppy like I just did last night, and snuggle up. And you guys want to see my puppy?
Yes.
One of those robots. Got like 3 other
I think I have a picture. No, that's not it.
Is it Chinese? Now, we're supposed to go to Korea and get a puppy. It doesn't count.
Well,
Pureed.
I don't have a photo. I thought I had a photo in my downloads, but I am wrong. I'll show you a photo next time. He's super cute. His name is Niles. He's awesome. So, anyways, it's great to snuggle with a puppy while you're reading. So,
What kind of puppy?
he's a standard poodle,
Okay.
red colored. It's like rust looking.
Pretty big.
They do get pretty big, yeah. But I don't know. If there was like a mid-size, I would do that. But there's only like big and then like pretty dang small and then super tiny. So yeah, those were the options.
That's miniature within a teacup.
I think that's in a teacup. Yeah. So this is sort of a schedule of the readings, and then notice we're really going to be spending 2/3 of the course lecturing on controls. Okay, so lecturing on controls is going to be 2/3 of the course. And so that will be more traditional. You guys have all had classes from me, so you know how that's going to go. It's going to be sort of like that. But remember that during that we're going to be having design meetings throughout. So it won't be just 3 hour, 2.5 hours of just lecture, 150 minutes, all at once. So we're going to kind of like slowly spread it out throughout the time. Because that's what I did last time. Was I just did 2.5 hours of lecture directly every time. I felt like people got a little fatigued towards the end. I got a little fatigued towards the end. So assignment 1 is up, and assignment 1 is the same as assignments 1 through 5, I think it is, or 1 through 4, because there was none this week. But next Wednesday we have class again, and we will be meeting and discussing the readings that we sent out, and so that I sent out. So you should be able to start them now. There might be enough reading to actually. I might not send you guys additional papers. There might be one that I'll send you this week, but probably won't be much extra. So this week, you'll write a response paper by next week with the following components: a 2-page or more summary of the content, and it must be thorough. Okay, so don't just be like, don't give me like a bullet list. Like it has to be like a written summary. of the ideas. So that one of the things that I think you don't get enough practice doing is writing technical content into a sort of report. Because when you do writing in your other classes, it's usually not technical. So I think this gives you a chance to summarize technical information succinctly and in your own words. So you'll be doing that. And that can be double spaced. So these will be double spaced. So 2 pages double spaced, which is like hardly like, it's like 4 sentences. So. And then a page or more research on a specific topic from the reading, or if I send you guys a paper, you substitute the paper for that. So how this is going to work is you're going to read the stuff and say it talks about, I don't know, some sort of manipulator arm or something, and it talks maybe about 6 degree of freedom machine, and you're like, well, I want to learn more about those. It was only a little discussion in the primer book. So you would go find 2 respectable sources. So they don't have to be academic articles. They could be textbooks. They could be websites that are good and have good information on them. There aren't a lot of websites that have good technical information on them, but there are some. So I am open to that if it's a good source. And then write up a description of what you learned about it and cite those sources. And then submit the response paper on Moodle. And I didn't mean to say that in Moodle we're going to be discussing. We're going to be discussing at the next seminar what is in those papers. So you bring them, or you can bring yourself a copy, but you're not going to turn them into me a copy. You're going to turn them in on Moodle. And then we're going to discuss them in class. We're not going to like put them up on the board and discuss them, but you're going to, hello, still here. Okay, it's not that dark. So, defeated by the machines again. Yeah, machines 1, us 0 so far. Okay, so we are, next week we'll start discussing that stuff. This week, since you haven't read stuff, and I almost sent you guys stuff to read this week before, but then I decided, well, you probably aren't spun up enough to get 6 chapters read by today. So I am still expecting you guys to read those first 6 chapters that are for the reading for this week. But by next week, there will be more chapters that you'll have read as well. And those will be the ones that you'll do your paper over, not the ones from this week. I'm kind of going to be summarizing a lot of it, so it'll be pretty easy to read because you're going to be kind of seeing a lot of the same stuff in the reading. The first 6 chapters. I mean, these are like chapter book chapters. They're like when you did the summer reading programs when you were a kid at the library, and they were like, here, read 3 chapter books and 5 of these other sorts of not quite chapter books this summer, and then you get a free ice cream cone or something. It's like that. It's practically like that. So, yeah, so the moral of the story is do the reading and get ice cream. Okay. And then we'll go from there. I don't in my other classes focus on the reading as much as I do on this class, because I think that the reading is a really important aspect of how you guys will be learning as you leave here. So I know that it's so nice to sit in class and have somebody lecture to you, and I love listening to lectures. But oftentimes with more advanced topics that you'll encounter, especially these sort of senior level elective course topics and beyond, there aren't a lot of lectures available, and when you're not in school anymore, there definitely aren't lectures available. And so it's the type of thing that you're going to have to start reading and understanding and discussing. And so that's part of why we're starting to change a little bit to this style, even though I will go back and do lectures for the control stuff, because there's just a lot to cover. So I'll do that. But we're getting a little bit of a sense of that. There's going to be one midterm exam in the class. It's not going to be over, and the date is pretty, I have it in week 8, but I don't really know yet where it's going to end up, because I want to do part of the control stuff first, and then we'll do a test over that control stuff. And then we'll have a final exam as well. The reading, you aren't going to really be tested over per se, because there aren't a lot of problems to do. I'm not going to give you guys an exam where you like fill in the bubbles, like definitions and stuff. I'm not going to do that. It's all going to be through discussions and through your summary papers. So, all right. So that is that. Let's see. Oh, resources. There's some resources available there that we'll bring up as we need them. Get on Slack if you're not on there. That's how I'm going to be communicating. It works so much smoother on Slack. I am so much more responsive. You guys would be proud of me, because you guys were in the year where I was really bad at email. I was bad the year before too, but I was really bad last year. And I heard you guys. You guys said, we would like more communication, better communication. And so I started using Slack this fall with all my classes, and I was so much better. Because I am going to get behind on my email, because I get way too many every day. But I can check Slack every day and respond to you guys, as you guys just come to the top of the pile. Because I can't, when I look at my inbox, it's hard to catch all of the student emails. So I was way better. So I tried to really do better at that. So hopefully that continues. So get on Slack. I sent you guys, so this link here, if you didn't get the email, this link here on the website will get you to the place you need to go to get logged in. You can download like a mobile app if you need to, or a desktop app, or you can just do it in a browser. Okay, so the project page we're going to discuss in just a moment. We'll come back to that. Homework, quiz, and exam policy. So it's the usual thing for me. Oh yeah. Totally don't even read that. That is not true. No quizzes. It's no quizzes during the seminar period of the course. There will be quizzes once we start having lecture and homework assignments. So we'll get to that point. Yeah?
Is that the same quiz style where you assign 1,000 problems and choose 3 of them?
Well, actually, so one of the things that I'm going to do is I'm going to give you guys, since I spread this material out more than I did last year, I'm gonna select fewer homework problems for each week. But yes, I'll assign homework problems, and then you'll do them, and then you'll take a quiz that will show you if you understood the homework. Is the idea. So, yeah. The current assignments that are up there were the ones that I assigned last year, but I'm probably going to tweak them. We aren't there yet. We're still 6 weeks away from those. So as we get closer, I'll tune them up. Exam policy. So I say that they're going to be in class, but I may decide to assign one or the other of them as a take-home exam, because a lot of this material is best done with a side of MATLAB. So I probably will end up doing at least one of them will be a take-home, just because you're getting to that point where it's hard to write exams that are effective if you're going to take them in class. I mean, I suppose we could do in class with MATLAB, like get the computer lab or something. We'll see. I'll think about it. But you guys writing code when you feel like you're under pressure, that's kind of hard. So, does that bring back any memories? You know? All right. So, grading policies. That is, it may look like 0.25%, but that just means there's only one of those little dots across. It ran out of room. Homework, quizzes, papers, discussion, participation, they're all going to be mixed into 25% of your grade. So that's a quarter of your grade. You gotta be doing the homework and the quizzes. You gotta write those papers, and you gotta show up and discuss. I mean, the seminar is really, really lame if it's just me up here asking you guys questions and nobody's responding. The idea is that it becomes a discussion, and what I'm gonna do each week, and you're gonna see kind of a little taste of it. It's gonna look a little bit different today because you guys haven't done the reading, but I will beforehand be preparing questions for us to consider and discuss. That will be kind of open-ended questions, so that they're not just like, "Oh, that's the correct answer, thank you," and now we can move on. So it'll be group discussions. And as far as participation goes, I recognize that everybody has a different personality, and there are people who will be more vocal than other people in the class, and that is fine, but I do expect everyone to be here participating actively in the discussion. And if you're never making any comments, then you should probably question whether you deserve a good participation grade. I'm pretty generous with participation grade in the discussions because I recognize people are different, but I also think that you should be engaged to the point where we can tell you're contributing. That would be great. Midterm exam is only going to be worth 20% of the grade. 25% of the grade is going to be the project. So it's pretty heavily weighted, the project, because there's going to be a lot of work involved with it. And we'll talk about what that work's going to look like soon. The final exam is 30% of the grade. Don't cheat. And then here are the correlation of the program outcomes, mechanical engineering program outcomes, and the course outcomes, and which are the most correlated that ABET loves. So this is all about. So you guys know how we got the ABET accreditation, and it's like everything's looking really good. I mean, I don't want to be immodest, but I think most of it has to do with how nice this table is with the check marks and the hovering highlighting. I think that's most of it. So, I don't like to toot my own horn, but sometimes it just needs to be tooted. So, sorry. So, let's talk a little bit about the project. Yeah, question.
Any variation between grad and undergrad?
Yes, so it didn't strike me because we had talked about you being in this, but I looked at the roster. You're the only one who's taking at the grad level, so we can talk about that offline a little bit because in the past I've done it a couple different ways, and since there's only one of you, we can discuss what might be the best way. What?
I just haven't turned in my paperwork yet.
Oh, you're gonna switch over? Okay, cool.
What if we all switched to 5?
Yeah, so you.
I want to very see. So it's a master's credit. So
Yeah, so most of you can, and I do encourage that. So if you should do it now because they won't let you do it later. But if you have any inkling that you might want to do a master's program, even somewhere else eventually, you will be served by being able to transfer this.
And also, they don't let you retake the same class. So if you took something as an undergrad, you cannot take it for graduate credit later on.
that's interesting.
There may be exceptions to that.
No,
But
I tried.
so they. So anyways, if you're interested in taking it as a grad course, so I'll tell you the ways that I've done this in the past, for the project, you sort of take on a leadership role in the project. So you lead a team who's working on this aspect of the project. So you have to, a lot of the communication will come through you, and you'll be taking the lead. There's also the research portion of the papers that everybody has to do a little bit of. You have to do an occasional presentation and during the seminar portion on the paper that you decided to read. There's a little bit more involved there, and I could talk to those students specifically. I don't require anything different really in the homework or anything like that, because the homework is for your benefit. So it's not like I'm going to give the grad student more homework so that they benefit more. If I thought that was going to benefit you more, I would have benefit you more. But I will. I mostly do it through the project and the seminar for the discussions and stuff. And I may also give you an extra paper on some weeks during the seminar to read, so you can report on that paper. So you're going to be asked to do some extra things, but it's not a lot of extra things. It's just some extra things. So I would say that it just would enrich your experience of this course to take it at the 500 level. It's going to take some more work, but it's not like I don't just add extra. I just don't like adding extra homework assignments because it just doesn't feel like, or extra homework problems because it doesn't feel like it makes sense to me. So I don't do that. So that's my take on it. So this is the page that, if I just clicked on it from the syllabus, the group projects page. So it contains the details of the group project. We want to build a reactive platform that will catch an object falling onto it. So I'm going to be the customer for whom you must design this platform. And also I'll be your guide, and I'll probably be the sort of leader of the whole project, I guess. Expectations. So I'm going to talk about expectations, and then I'm going to move on, and we'll come back to this at the end because we need to go through the customer needs and design requirements stuff, and that's going to be a sort of part of this class today. We're going to spend some time with that. Yeah.
Is the platform going to be predictive or responsive?
So it depends on what you mean by that.
Is it going to be predicting the object falling onto it, or is it going to have some sensor to react to something falling?
So I guess it depends on how you guys want to design it, because as the customer speaking now, I don't care. As your guide, I might have some opinions, but I think that they're both potential options. So one thing, when you have something that's not aware that something's about to fall on it, it's not going to be moving yet, right? And so you have to be able to move pretty quickly, otherwise it's going to smash against the platform, right? It's going to hit it pretty hard. So you have to start moving at least pretty quickly, otherwise you're going to have that impulse peak that's going to happen when it makes impact. So you're either going to have to move really quick when it first hits, or you're going to have to predict that it's going to hit soon and start moving before. So there are two different ways you could go about doing that, and as the customer, I don't really care how you do that, because I just want you to catch something, and I have some specific requirements for that you guys got to chat with me about. But in general, yeah, you could have something that detects something falling, start moving the platform, and then catches it. So it may be that we can get away with one and not the other, or maybe we can get away with either one depending on how we do it. Yeah.
Is the product output supposed to be continuous? As in if you're doing can production, you're gonna get a can every time. It's pretty much guaranteed.
Oh yeah.
So is it like potato chips? When they were baking potato chips, the level of chips is different, so these chips are going to fall different than those chips, and the output's going to change.
Yeah, so there will be it's not always going to be exactly the same part that's going to fall, but there are some characteristics that we can bound all of the parts inside of. They will all be within a certain weight range, geometry, etc. So that's part of the process that we'll undergo is making specific what it is that I need, because I'm a customer who may or may not know much about engineering, and I don't really know what to tell you. I'm just telling you I want something that catches these things. I'm a process engineer. And I'm thinking high level here. I don't know how you're going to do it. I just want you to do it. Okay. Nothing against process engineering. Okay. So these are the expectations that I have of this project, of you guys in this project, and how this should go. Okay. And I think that it's important that I explain it very clearly up front, day one. And then once I do that, we'll have covered everything about this course as at a sort of an administrative level. And then we're going to embark upon the seminar section of today. And then we're going to end by coming back to the project and discussing how we can sort of wade into the details and how we're going to organize ourselves. Okay? So, my expectations are that the following things should result from this project. We should make a design that meets the customer needs. Okay, so that's always got to be the goal, right? You gotta do that. So a design is one thing, but I'm actually requiring that we have a working prototype of the design. So not just design, but also build. Yep.
What's the scale of the prototype?
Yeah, we're talking a pretty small scale, so we'll talk a little bit about what the requirements are, but it's going to be something that can fit on a bench top pretty easily, because I don't want you guys to have to build some massive piece of machinery.
Catching marbles or something.
Yeah, catching objects. The things that you're going to be catching are going to be about yay big or smaller. Like, you're not going to be catching anything this big. You're catching things like this big or smaller.
Snow globes.
I actually, snow globes, that would be interesting. If this thing is, functioning well, I think there could be some really fun things we could drop on it and see if we can tune it so that it could let those things land. But we're going to be aiming for something that's not super hard. Like, we don't want to we don't want to start off with the egg requirement, because in a manufacturing environment, if you're using eggs in it, this is just what we're talking about here is just probably not, you're never going to just drop the egg. At no part in that process is going to be like, yeah, let's just drop this egg and we'll catch it. It'll be great.
How far is it going to fall?
We'll get to that, but it's not a long distance. But it's going to be like.
Not going to throw it off the top of the building or something.
No, nothing like that. But I think that could be fun though, because if you can make it catch the things that we're going to aim for, we might be able to tune it to catch some fun things like an egg, right? Like, maybe it will work. Maybe we can make it work, which would be cool. It wouldn't be part of the requirements, but that would be a cool demo. To be able to drop an egg on it and have it just go whoosh, and it's part of it is not just to catch it, but to return it to the original height. So it's all part of the fun. So it's going to be cool. It's going to be fun. I like this project. So prototype. 3, a thorough report of the design that includes, but is not limited to, the following list of things: an abstract, an introduction, description of the customer needs, a description of the design requirements, a thorough description of the design, including drawings, a description of how the design meets the requirements, a theoretical analysis, simulation results, and experimental results. Oh, and not just that one, and a discussion of the overall design and its performance. Okay? So this is like, once you finish this report, you should be able to go back to this for the rest of your career and look at how this design process was successful at getting at all the requirements, or maybe you guys couldn't quite hit one of them and there were some reasons why. That's fine. But we always aim to satisfy all of them. Maybe there's some constraint, like maybe we just don't end up with the budget that we needed to get the piece of equipment that was going to help us. But I don't think we're going to run into that in this project, but we may.
There's no budget? Or is that what you're saying?
What I'm saying is there is a budget yet to be determined for this project. And what I'm going to suggest is we think without the constraint of budget for a while and just talk what are the best possibilities. And then we think, okay, what kind of constraints do we have money-wise, and where does that leave us? What designs could we follow?
This
Yeah.
paper we're going to be writing, is it going to, I'm most part focused on the individual portion you're working on. So
No.
we're going to subdivide this into a bunch of different smaller sections. So we're going to be writing this paper on the entirety of the project, or are you going to be writing your paper on the section you're working on?
There's only going to be one paper,
Okay.
so everybody contributes to the one report.
One paper
For the whole group, there will only be one paper, and so that means that I mean I am leaving room in this for people's participation in it. So you only get the full grade if you fully participated in it. So there is that aspect. Like the light sensor used to be better in here. All right. All right.
It looks like it.
So, and then we're going to end the semester with a presentation that's going to be open to the public. I mean, mostly just people on campus, I don't know, but people from outside can come. Because I think it's going to be a really cool project, and senior design is going to be happening, so there's all that going on. But there's often interest in cool stuff, and this is the type of project that I think could attract people to come in and see what you guys have been doing. So we'll do a nice spiffy presentation. I'll even see if they'll get us coffee and cookies to attract people. Yeah. If they, yeah. I'm not allowed to just bring coffee and cookies. Maybe, I don't know.
Open bar.
Open bar. If we were the board of trustees, we would have open bar. I went to one once. They had a meeting, and it was sweet. It was great.
What is the engineering banquet this semester?
I don't know. It's a good question. I haven't heard anything about
It's
it.
been late in the semester because apparently everybody wants us to participate in presentations.
Yeah.
It's like,
Yeah.
Yeah, I'm just more concerned for the open door.
All right, so that is all of the sort of administrative aspect of the course. So that part is done. So we're just getting to the end of like the first class period. This was like Monday just got over. And so I'm going to try to break it up a little bit. So let's go ahead and take a couple minute break, and then we'll come back and continue.
do you have any requirements as to how this paper, what format it's written in, type thing?
Yeah, it needs to be written in LaTeX. Yeah. Yeah.
I just wanted to make sure.
There's no other way. There's no other way.
What
And
is Microsoft?
I am not open on that one, I guess.
Big places.